Hello and welcome back to another video. Today I thought I would share my interview step-by-step process on how you actually can go through an interview in a very systematic way. I think it helps to understand how to structure an interview as an interviewee optimally, and with some tips and tricks on how you can give better signal than maybe other candidates. So let's dive into this. So obviously, the first step is really to understand the problem, and you will see me in the LeetCode videos that I first read through the problem description, and that I make sure that I understand what's actually being asked, right? And this is extremely important, and because if you start on the wrong track, well, you might just end up somewhere where you didn't want to go, and by that time you will have failed the interview. So this step is really important, and I also recommend that you read the problem description out loud, because every time you're silent in an interview, the interviewer is just wondering what you're doing, right? If you've ever been in the interviewer position, you know how awkward it is when the other person doesn't say anything, because you don't know if you need to jump in and help. You don't know if that person has a question. So your job as someone who's being interviewed is it really to walk the interviewer through your thought process and at all times let them know what you're currently doing or what you're thinking about. It's perfectly fine to say, oh, I need a couple of seconds to understand this, and then go quiet for those couple of seconds. Especially when you're not used to talking through your process. In the beginning, you will probably have to do this more often than not. Don't be afraid to announce exactly what's going to happen next in an interview. It's just so much better than having somebody sitting there who's quiet. Now, the next step is, after you understood what the problem is, and to understand what are some of the constraints of the problem. On LeetCode, you always have the constraint listed on the bottom right of a problem. In an interview, the constraints are usually not given to you for free, so you actually have to ask for them. Let's say if you're getting an array, you want to ask if the array can be empty, or are there duplicate values in the array? Is the array sorted? This type of stuff. And value ranges could also be important for some problems, to understand what values are in the array. For example, if you're giving a tree something, you're typically giving a reference to a tree node object. So you have to clarify that. In other cases, you might be given an array representation of a tree. So you really have to understand what is the structure of the input, what is the format, what are some of the edge cases of that. Can the tree node that you're given be none or no, right? So to represent an empty tree. And also in other times, it's unclear on how you should handle these edge cases. So if, for example, the task is return the minimum node in a binary tree, and you're giving a tree object as the input, so you figured out it's a tree object, you'd ask, okay, can that be empty? Is it possible that that there exists no minimal node because it's empty? And if the answer is yes, you should probably ask, okay, what should we return in that case if we can't find it, right? And then they will tell you it's fine to return maybe -infinity or just -1, or just the value none itself. So you have to figure all of that out, and people underestimate how much this will help you to later not have to ask any questions. It's always a little bit suboptimal if you're going through your implementation later, and then you have to ask about an edge case that you could have asked in the very beginning. But you didn't ask it in the very beginning because you thought that wasn't important, right? So really use this clarifying constraint phase to ask anything about the input, even if you don't think that you're going to need it, but you should cover all the typical questions. Empty values, null values, how to handle that, blah, 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 etc. It'll just look you, well, I guess more organized if you don't have to then follow up questions halfway through your implementation. But that can happen, of course. But yeah, I'm just telling you what would be the better way to do it. Anyway, so the next step is then, well, you know the inputs, you have understood the problem, you already have a good idea of what the edge cases can be. And so now it's time to work through a couple of examples that you're trying to solve basically by hand. And on LeetCode, you're giving the examples, right? You can, they are below the problem description, so you can just use these, and that's what we do in the videos. But in a real interview, you're likely not giving any examples, or maybe just one. So you have to come up with your own examples in many cases. You could also ask for an example, you know. If, for example, if I were to find a minimum node maybe in a tree, you know, I would come up with a couple of tree examples. And if I know that the tree can be none, I want to work through that edge case where the tree has no nodes. And what is surprising, I guess, to many people is that if you try to solve the problem on hand or on a whiteboard without writing any code, but you're kind of stepping through the arrays or through the reference of the linked list or the graph that you're traversing, you more often than not, you will at the very least identify the brute force approach. Because the way you're solving this problem on a whiteboard, virtual or a real one, well, that process helps you to discover, you know, what the algorithm could be to solve that with a computer program. And hopefully that'll happen so that after working through some examples, you have a good idea of, you know, how you could solve it. At least you have one approach. And if you don't, you know, you can ask the interviewer for help. You can say, I'm not seeing a pattern yet. Do you have a suggestion for another example case that I should work through? You know, ask for a hint actively. Let the interviewer know what's going on. It's worse to not say anything and just keep stabbing in the dark than saying, hey, I need some help here. Because if you then get back on track, you know, it's not going to be that severe that you ask for help. And so this is this can be an uncomfortable moment where you only see the brute force approach or you don't see anything. But trust me, practice through that, practice handling that. It'll make you look so much better than failing when you encounter a problem where you don't know the solution at first look. And I know it's tempting with LeetCode. You practice so many examples. More often than not, you recognize a problem, you immediately know the solution, easy peasy, right? But the interesting stuff happens when you don't see the best solution yet. And when the interviewer can see how you work through that. And by keeping at it, more often than not, you're going to find a brute force solution. And you're also going to find a more optimal solution. And maybe you don't even have to implement it and just describe how that works, right? So this is a crucial step. Don't let perfection be the enemy of the good. When you run into this problem, and you will see I have some videos where I show how I struggle with that, with some problems as well, even problems that I've solved before. That's absolutely normal, right? There's no shame in that. It just means you have to continue to practice. That's all that means. So next step, the fourth step is, well, explaining your approach. So just to recap, you understood what the problem was, you understood the constraints and edge cases, and the format of the inputs and outputs. You now have an idea of what one approach could look like. If you're lucky, you have multiple approaches already in your mind. Now it's time to explain, right, after running through the examples, now it's time to explain to the interviewer what approaches do you see and how you would like to approach this problem. And then you ask the interviewer if it's okay to proceed with that implementation. Most people don't do a good job when they have to explain the trade-offs between approaches. Let's say there is a linear time. Yeah, oh yeah, finding the minimum. Well, no, what could we do? I don't know, but imagine you have one problem where you have linear time and constant space. That would be maybe the brute force approach, right? And you could also have another solution that has quadratic, that has, let's say, logarithmic time, but also logarithmic space. So now you have two problems. One has the benefit of having constant space, and the other one has the benefit, not problem, the benefit of having logarithmic time, but not constant space. So yeah, so you have to explain these trade-offs, and that gives the interviewer a good signal, right? That you're able to analyze the problem, that you analyze to reason about different approaches and their drawbacks and their benefits. That's really going to give you lots of points in terms of giving good signal to the interviewer. And now, extra bonus points is, when you are able to give the runtime and space complexity for your approach or for your multiple approaches before you write the first single line of code. I believe it's so uncommon that interviewers actually don't even expect you to do that. That's just my impression. But if you can do this at this point already, right, it'll be unusual and it will be another strong signal. Typically, people are only asked to do a runtime and space complexity analysis after they actually implemented their code. But that's easy, right? But it's more difficult to do it just as you're talking about your approaches, because if you can do the analysis, then you've understood the problem fully and you know exactly how you're going to implement it. Right, so now we ask the interviewer, should we start implementing the brute force approach? And maybe says, no, it's too easy, just let's continue with the other one that has the optimal time complexity, and then you proceed with implementing that one. Now, very important, when you implement the solution, communicate your thought process while coding. Most people go silent. You don't want to go silent. You actually want to speak as you type and explain exactly what you're doing right now. That's what I'm also trying with all my other videos. They're all practice videos where I'm trying to get better at that process. Yeah, you should do that too. And of course, you should pay attention that you write clean and readable code, that you use good variable names, you know, all the standard stuff. And also make your code a little bit modular if that adds clarity to understanding your code. There was one LeetCode problem to find the minimum in a left rotated array. And you could break down this problem into two steps. One step is to find the minimum index and then perform a binary search knowing what the offset to the minimum index is. So that's a natural, well, I would say split point for how you can divide your code into two functions. One does the finding of the minimum, the other one finds the value in the the target value in the array, in the sorted array that is shifted using binary search. So even though you could implement it in one loop, in one while loop, you know, structuring your code like this shows that you have a clear thought process. And it's really more about your thought processes than writing one less loop that doesn't save any time in your complexity analysis. Yeah, and then once you've implemented your solution, there are going to be bugs. That's almost a guarantee, unless you have maybe implemented that problem multiple times before. So it's really important before you hit the submit button, if there's a way to test the problem, that you review your code line by line and talk through it, explain what is happening. It'll help you to spot where your code has logic errors. Because so far you've been explaining your approach, you've explained your implementation. If you now walk through your code and explain it again, and you see something that's inconsistent, it'll stand out. You will notice it immediately. You'll be able to fix logic errors. You will also probably find some syntax errors. And those are, the logic ones are important to eliminate. The syntax ones are maybe not as critical, but it always looks better when you have a code that's absolutely flawless as soon as you hit the submit button. So you're trying to optimize that and to have less errors. And you're also showing that you can actually, well, analyze your code for bugs, right? So that's another part of showing your systematic approach and how you make sure that everything is fine. And another thing you should do is you should basically use the example case that you came up in the earlier steps and just walk with them through your code, right? So you can combine that with the line-by-line review of your code if you want to, but you can also do that separately. And yeah, this is just taking the input, explaining, okay, what is in which variable, what happens when we call this recursive function, blah, blah, and really just walk through the entire example until you come to the output value. Check your edge cases as well. And when you're convinced that everything's bug-free, you say, okay, I think we're good. Do you have any more questions before I submit this code? If there's a way, to submit the code for test cases or whatever. Yeah, and well, that's pretty much it. So just to summarize, first understand the problem, read it out loud, clarify all the constraints, even the ones that you don't think you might need. Work through the examples by hand to discover how you might implement a solution for this problem in code. Explain your approach in runtime, what data structures you're going to use, what techniques you're going to use, maybe sliding window or two-pointer or binary search or whatever it is. Then implement the solution and talk through your implementation while you're doing it. Don't be silent. Then be the debugger to check your code and to test your code with the test cases or the examples that you came up in the beginning. And that's pretty much it. So that sums up the whole systematic process. As you practice this more and more, you will find your own style of how you're going to communicate. But this is a really useful guide that I think will help you out quite a lot, right? So just try to hit the main points, and you have a lot of flexibility on how to do every single point. I gave you some pointers on how you might, or what you might want to aim for. But yeah, if you do this in an interview, you're going to look super structured. You're going to look like you know what you're doing. And if you make a mistake, you have the ability to shine by working through it and getting it to work anyways by working through the examples. The one place where you don't want to get stuck is in the debugging phase, where you run your code, something's wrong, then you fix it, then the next thing's wrong. So you don't want to enter this, poking in the air kind of approach where you just poke at your code, trying to fix things, but there's still an error when you try to submit it. So yeah, anyways, that's all I have to say for this one. I hope you find this video useful, and I encourage you to use that in your mock interviews or in your own practice interviews when you talk to LeetCode.